After watching the film The Framework, you might start to wonder about the growing realism of computer games. As technology advances, these digital avatars and worlds seem almost lifelike, leading us to question, could these characters actually be real? Perhaps the person who presses play on a video game is simply dreaming, and we, as players, are part of that dream. This leads us to contemplate the nature of existence itself and the grand questions about the universe. What lies beyond our reality? This question has intrigued philosophers and scientists for centuries, and likely will continue to captivate future generations. It's a question so vast that scientists are still unable to measure the full extent of the observable universe, and this only accounts for the part of the universe we can detect. It doesn't even consider the unobservable portion. Despite the growing knowledge about the universe, we are still left with the immense mystery of what lies beyond. The ancient thinkers had some ideas about this. For example, the idea that we are just particles and nothing more, the essence of materialism, remains a view we explore today. The observable universe, which refers to the part of the cosmos we can see and study through telescopes and instruments, is vast but finite. This is because the speed of light, which is the primary way we gather information about the universe, is limited. This limitation means that we can only observe objects and events that are within a certain distance of us. Anything too far away or that happened too long ago is beyond our reach. The observable universe is estimated to be around 93 billion light-years in diameter, which is far greater than the age of the universe itself, believed to be 13.8 billion years old. This discrepancy arises from the expansion of the universe, which causes objects that were once close together to move farther apart. As the universe expands, light from these distant objects takes longer to reach us. The observable universe is, therefore, a gigantic and fascinating place, and there's still much we don't know about it. However, with the help of advanced tools like NASA's James Webb Space Telescope, we continue to learn more about the structure, composition, and history of the universe. But what lies beyond the observable universe? If the universe is only 13.8 billion years old, how can it be 93 billion light-years across? And why do we have so little knowledge of what lies outside of it? To reach the edge of the observable universe, we'd need technology that could transcend space-time itself, through concepts like warp drives or wormholes, which scientists have long speculated could be possible but are considered highly improbable with current technology. The theory of cosmic inflation suggests that the total size of the universe is at least 10 times larger than the observable universe, and this number is so large that it's essentially immeasurable for us. This means that we have no practical way of knowing what exists beyond the observable limits of the universe, but that doesn't mean we can't come up with hypotheses. We can speculate based on the information we do have from distant galaxies, and NASA has been instrumental in advancing our understanding of these vast concepts. Before the James Webb Telescope, NASA had already provided deep-field images using the Hubble Space Telescope, revealing new insights into the early universe. The James Webb Telescope's first images unveiled galaxies farther than we had ever seen, showing them as they were just a few million years after the Big Bang. Because the universe is expanding, the light from distant objects shifts to longer wavelengths, or redshifts. This allows the James Webb Telescope to detect infrared light, revealing galaxies that formed in the early history of the universe. In studying these distant galaxies, researchers have been able to observe the rate at which stars were forming in the early universe. This led to the discovery of 44 galaxies that were previously unknown, which date back to just 300 million years after the Big Bang. These findings suggest that a significant number of galaxies were forming stars much earlier than we thought. The search for extraterrestrial life has always been a captivating question. With new discoveries in the observable universe, it seems increasingly likely that other galaxies harbor life. The James Webb Telescope's discovery of an exoplanet called WASP-96b supports this idea. This planet, located far beyond our solar system, has a light spectrum that reveals the presence of water molecules and clouds, features that were previously thought to be absent from such planets. The possibility of life in these conditions suggests that we might not be alone in the universe. Considering the vastness of the observable universe, the idea of a multiverse, multiple separate universes, becomes a tempting hypothesis. The concept of the multiverse suggests that there could be an infinite number of universes beyond our own, each with its own unique properties and laws of physics. This idea remains a theoretical concept, but one that continues to intrigue both scientists and philosophers. In the end, the search for answers to these profound questions about what lies beyond our universe continues to push the boundaries
concept
of
of a
human
multiverse
knowledge and imagination. Proposing the existence of multiple equal universes or dimensions beyond our own is often explored in the context of quantum physics. Quantum physics deals with the behavior of small particles such as atoms and subatomic particles. According to some interpretations of quantum mechanics, the act of observation can cause a quantum system to collapse into a single state. However, the many worlds interpretation suggests that observation actually causes the system to split into multiple states, each representing a different outcome. Although the idea of a multiverse remains highly theoretical and lacks concrete proof, it continues to intrigue many scientists and philosophers. Some view it as a promising tool for explaining certain phenomena, while others are skeptical of its validity. Nonetheless, the possibility of a multiverse still holds weight, as we are unable to know what lies beyond the observable universe. This leaves open the question of whether structures such as dark flow exist beyond our universe, a complex inquiry in itself. Dark flow is a phenomenon proposed in 2008 to explain the unusual movement of galaxy clusters, which appear to be traveling faster than expected based on the distribution of matter in the universe. The dark flow hypothesis suggests that these galaxy clusters might be influenced by some form of unseen or dark matter or energy pulling them in a particular direction. However, the existence of dark flow remains uncertain, with some studies suggesting it could be real and attributed to a massive unseen structure, while others argue that it could be the result of measurement errors. In either case, dark flow might be a phenomenon that exists beyond the observable universe. Similarly, the existence of black holes, regions of space with gravitational forces so strong that nothing, not even light, can escape, is another puzzling mystery. Black holes can form when a star collapses at the end of its life, and they can range from a few times the mass of the Sun to millions or even billions of solar masses. The challenge of determining whether black holes exist in the unobservable universe arises from the fact that this region lies beyond our current observational reach. While it's almost certain that many black holes exist throughout the universe, we cannot yet confirm their presence or properties beyond the observable universe. As for dark matter, this is a speculative form of matter that is believed to constitute about 85% of the universe's mass. It is called dark because it does not interact with light in the same way that ordinary matter does, making it difficult to detect directly with telescopes or other instruments. However, its presence is inferred from its gravitational effects on visible matter, and its ability to bend light from distant objects. Although dark matter is widely accepted by the scientific community, it remains poorly understood, and its exact nature and behavior continue to elude researchers. Some theories suggest it could consist of particles that have yet to be detected. The existence of dark matter, like the possibility of a multiverse, remains a mystery that could potentially be resolved by exploring beyond the boundaries of the observable universe. In the quest to understand the universe, NASA's James Webb Space Telescope, JWST, plays a crucial role. Designed to observe the most distant objects in the universe and provide images and spectra of objects within our solar system, the JWST is also expected to study the atmospheres of exoplanets and offer insights into the formation and evolution of galaxies and stars. While the telescope is still in the process of being launched and commissioned, once operational, it is expected to make significant contributions to our understanding of the universe. It may uncover new and surprising phenomena that challenge our current knowledge, potentially leading to discoveries beyond the observable universe. While advancements in science and technology, such as the JWST and other future instruments, may one day allow us to observe more distant objects and events, it is uncertain when or if such observations will become possible. In the meantime, researchers continue to study the observable universe, working to understand its structure, history, and the laws of physics that govern it. The unknown remains a source of both fascination and fear as we look to the future of scientific discovery.